welcome to your weekly briefing for December 13th through the 20th, 2025. If you're trying to get a handle on the global semiconductor industry right now, there's really only one way to think about it. Forget about a 100-meter dash. What we're watching, what we're all a part of, is a precision marathon. And this isn't just any race. This is a grueling test of endurance, of long-term strategy, and of just massive resource allocation. And the runners? They're not just the tech giants we all know and follow. No. This entire game has been elevated. It's now a strategic showdown between entire nations. In this marathon, it's not about who gets off the starting block the fastest. It's about who has the stamina, who has the deepest pockets for R&D, and whose supply chain can take a punch and keep on going. Every single move, every decision, could very well decide what the global tech landscape looks like for the next decade. So here's how we're going to break down this marathon. First, we'll look at the foundry leader who's just pulling away from the pack. Then we're going to zoom out to the geopolitical race, where governments are literally setting the course. After that, we dive into the AI arms race that's fueling all this. Then we'll tackle the massive reshaping of the global supply chain. And finally, we'll look ahead and try to forecast what that next lap is going to look like. Okay, let's get right into it. The first battleground, the foundry business. This is where the magic happens, right? Where the world's most advanced chips are actually made. It's easily the most critical leg of the entire marathon. It's also where the gap between the frontrunner and everyone else is just, well, it's staggering. What we're seeing isn't just a lead, it's pretty close to absolute dominance. Take a look at that number, 72%. Seriously, just let that sink in for a second. In the third quarter of 2025, TSMC captured 72% of the entire global pure-play foundry market. That means one company controls almost 3/4 of the world's most critical manufacturing capacity. This isn't just about pricing power, which of course they have in spades. It creates this powerful, almost unstoppable feedback loop where their massive profits get reinvested, pushing them even further ahead. The strong just keep getting stronger. So the big question is, how did this gap get so wide? Well, it all boils down to one simple, brutal word: yield. In this business, yield is everything. It's the percentage of perfect chips you get from every single wafer. And right now, TSMC is just executing flawlessly. We're talking high, stable yields and a super strong ramp-up of their 3-nanometer tech. Meanwhile, Samsung has been struggling with its own yield ramp-up, and it's costing them market share. Look, if you're a company like Apple or NVIDIA and you have a multi-billion-dollar product launch on the line, you absolutely cannot risk unstable yields. So where does the money flow? To the safest bet. And right now, that is TSMC, period. And here's the kicker. What makes that 72% number even more wild is that the entire market grew by a massive 29% year over year. And TSMC? They didn't just hold their ground. They basically devoured all of that new growth. What's fueling this fire? It's the insatiable demand for high-performance computing chips for AI, the constant push for better chips in our smartphones, and even policy support in some key markets. These are the hottest growth areas. They all need the absolute leading edge, and TSMC has built a fortress around it. Okay, so we've seen the competition between companies. Now, let's pull the camera way, way back. We're moving from the corporate racetrack to the global chessboard. This next battleground is the geopolitical chip race. And trust me, this isn't just about business anymore. This is a high-stakes strategic game where national security and global influence for the next 50 years are on the line. This timeline really shows you why we're calling it a marathon. Nations are making moves now for a payoff that's a decade away. You see China announcing a prototype EUV machine this year, a massive step for their own tech independence. Then you've got global equipment sales set to peak in 2027, which is basically the height of the current fab-building frenzy. Look further out, Japan's getting back in the game in 2029, and the US is aiming for a huge 203% boost in domestic manufacturing by 2032. Every single point on this timeline is a national statement of intent. And to put a number on that 2027 peak, we're talking about $156 billion. That's a new all-time historic record. Now, this isn't just companies buying new tools. This is a direct reflection of a global, state-sponsored arms race to build out manufacturing capacity and completely redraw the map of where the world's chips are made. And to make this happen, governments are pulling out all the stops. I mean, look at this. In Japan, the government is basically co-signing for 80% of the private loans for their national champion, Rapidus. In the US, the CHIPS Act is going right to the source, funding critical materials like gallium. China's EUV development is being treated like a state-run Manhattan project. And even Malaysia is carving out a smart niche for itself, building the first big power chip fab in the ASEAN region. This race has become a full-on clash of national industrial policies. So we've seen the national strategies. Now let's drill down to the engine that's driving this whole marathon forward: artificial intelligence. The demand for AI compute is so massive, it's fueling a technology arms race on a scale we've just never seen before. And the battles are everywhere, from new materials and chip architectures all the way to software and packaging. It is an all-out war of innovation. In this kind of arms race, the big players are using acquisitions to build protective moats around their businesses. Take Qualcomm buying Alphawave Semi. It's like having a monster V12 engine. You still need a world-class transmission to get that power to the road. Alphawave provides that transmission, the super high-speed connectivity IP. Then you have NVIDIA buying SchedMD. Now this is fascinating. NVIDIA knows that killer hardware isn't enough. You have to build a software ecosystem that's so good, customers can't leave. This move makes their whole platform stickier, locking customers in for the long haul. Okay, let's nerd out for a second on a really cool piece of next-gen tech, the glass substrate interposer. Japan's Rapidus is developing this for their 2-nanometer process. So what is it? Well, modern AI chips are made of smaller chiplets all packaged together. The interposer is the bridge that connects them. Traditional materials are hitting a wall, but glass has way better electrical properties and it handles heat better. This means you can pack things tighter and run them faster. It's a potential game changer and a huge strategic bet for Rapidus in the new battleground of advanced packaging. And this wave of innovation is happening literally everywhere. You've got startups like Mythic raising $125 million for a new kind of analog chip. Think of it like a dimmer switch instead of a regular on-off switch that promises 100 times better energy efficiency. You've got new tools like Siemens' digital twin platform for cars. And get this, the very software we use to design chips is now being powered by AI. Keysight is putting AI assistants right into their design tools. It's this incredible feedback loop. We're not just building AI is now helping us build the next generation of technology. All right, after that deep dive on tech, let's talk about the logistics. This is our fourth battleground, the complete reshaping of the global supply chain. For decades, the name of the game was just-in-time efficiency, which led to everything being concentrated in just a few places. Well, those rules have been thrown out the window. The goal isn't just efficiency anymore, it's resilience. The new mantra is just in case. And under these new rules, this key idea has emerged: strategic redundancy. It's a fancy term for a simple idea. Don't put all your eggs in one basket. The pandemic and all the geopolitical tension showed us just how fragile that old model was. So strategic redundancy is all about building a plan B and maybe even a plan C. It's a fundamental shift in mindset, from just maximizing efficiency to actively managing risk across the entire system. And you can see this shift happening in real time, all over the world. Let's take a quick global tour. In the Americas, TI is ramping up a huge analog fab in Texas, while Korea Zinc is building a critical materials plant in Tennessee. Over in Europe, you have Quantum Diamonds setting up shop in Munich for cutting-edge sensing tech. And in Asia, beyond the usual hotspots, Malaysia's ChipX is building that specialized power chip fab. It perfectly illustrates this move away from having one single point of failure and towards a more diversified, regional approach. But here's the thing. Is just building more factories enough? Not even close. There are two other critical parts to this race: diplomacy and talent. First, diplomacy. You see nations scrambling to forge chip diplomacy to lock in reliable partners. But second, and this is arguably the biggest bottleneck of all, is talent. Think about it. You can build a multi-billion-dollar fab in about 3 years. It takes a decade to train a world-class engineer to run it. The real chip race, the one that's going to play out over the long term, is the race for alliances and for human capital. So we've covered the foundries, geopolitics, the AI frenzy, and the supply chain scramble. Where does that leave us? Let's try to synthesize all of this and look ahead to the next lap of this marathon. What are the critical turns coming up, and what is it really going to take to win? This quote just nails it. The entire industry is caught between two massive and, in some ways, competing forces. On one hand, you have this short-term explosion in AI demand that's like a shot of adrenaline, pushing everyone to sprint faster and innovate like crazy. But on the other hand, you have the slow, deliberate, long-term regionalization of the supply chain, which demands patience and careful strategic planning. It's a race for speed versus a race for endurance, happening at the exact same time. So it all comes down to that tension, sprinting for AI while pacing for resilience. And that brings us to the final, and I think the most important question for all of us to consider. In this incredibly complex precision marathon, what will be the ultimate bottleneck? Is it going to be capital, with these projects costing tens of billions of dollars? Is it going to be technology, as we push against the absolute limits of physics? Or is it going to be talent, the human expertise that takes the longest to build and is the hardest to replace? Capital, technology, or talent? That is the strategic question that will define the winners and losers in the next leg of the semiconductor marathon.